In this video, we will be having exponential equations practice questions. So basically we'll be answering these 6 problems that are about exponential equations. If you haven't watched the previous video about a brief introduction to exponential equations, you may head there first before entering this video to ensure proper learning. So yes, let's continue for number 1. For number 1, we are given an equation 3 raised to 3x plus 6 is equal to 27 raised to x plus 2. Just so you know, exponential equations, when we solve these problems, we do have algebraic manipulation. We apply the lessons that we've learned back in elementary algebra. So applying that lesson that we've learned before, we proceed to basically making whole numbers into smaller numbers. That might not make sense right at the moment, but let me explain. So in this problem, we are given the bases 3 and 27. Now, there is a specific rule that I've mentioned earlier that we have to decrease these numbers. Basically, we have to decrease the bases into smaller numbers. And our main goal is to provide that we have made these numbers smaller. They should be cancelable. Both sides should have bases that are the same. So that's the sense of having exponential equations. We have bases that can derive, that can be brought to the same base. So here, we have 3 and 27. 27 can be translated into 3 raised to 3, since 3 times 3 is 9, and 9 times 3 is 27. So as we can see here, we have two bases that are the same. So that is our main goal. And provided that we have x plus 2, apply distributive property, this will become, let's make the eraser smaller. There you go. So 3 times the quantity x plus 2, we get 3x plus 6. Now, we cancel the base, and our exponent will become our base. That's simple. Okay. Then we have to solve for x. So 3x minus 3x is 0. And 6 minus 6 is 0. Therefore, our answer, is an element of real numbers. In other words, XER. There is no specific number for x as seen here, since 0 is equal to 0. Therefore, it's an element of real number. Now, for number 2, we have bases 3 and 81. So I think we could all agree on the fact that 81 can be divided by 3 multiple times. I mean, I'm not sure how to say this, but in this sense, all we have to do for 81 is to make it smaller, since 3 raised to 3 raised to 4 is 81. So yeah, that's it. You just cancel both bases. We have to make the bases the same so we can cancel them. Should the bases not be equally possible to one another? I'm not sure about that situation. But usually, we can see that exponential equations usually have bases that can be the same. Suppose that you'll be able to simplify them. So exponents before become our bases now. So 4x minus 4x is 0. Transpose 3 to the other side, we get negative 3. 0 is not equal to negative 3. Therefore, we have a null set, or in other words, no solution. Okay, let's move to number 3. Let's just move this. There we go. Okay, we know that 4 and 2, the lowest number could be 2. So 2 raised to 2 is 4. 2 raised to 2 times the quantity of 2x plus 3 is 2x plus 6, which is equal to 2 raised to 2 raised to 2. You have to simplify this, the distributive property, 2x plus 2. Then we cancel the bases, 2 and 2. We place the exponent now in the base place. So 2x minus 2x is 0, and 2 minus 6 is negative 4. 0 is not equal to negative 4, therefore, our answer is no solution, or a null set. Okay, let's move to number 5. Sorry about that. Okay, we know that 625 can be reduced to, can be equal to 5 raised to 4. I'm sorry. Yeah, 5 raised to 4. I'm sorry. 5 raised to 8. Apply distributive property there. 8x minus 8, which is equal to 5 raised to 4. 5 raised to 4 is equivalent to 625. 5 raised to 4. 4 times the quantity 2x minus 2. We get 8x minus 8. And with that said, we cancel the base and we make the exponents our new bases. So 8x minus 8 is equivalent to 8x minus 8. I think it's already obvious that these expressions are equal as an equation, but let's try to simplify it a little more. We'll solve it one way or another. We'll do the long cut since this is a lecture. You have the liberty to not do this, not take the long cut. You can just be better off with this. You can just say XER. That's it. But for the sake of everyone, for the sake of those who aren't really as trained in terms of this lesson, we'll be solving both parts. So 8x minus 8x, then at the other side of the equation we place 8 minus 8. Then yeah, basically we get 0. And similar to our situation in number 1, our answer, our x, is an element of any real number. Okay, so for number 5, let's move the problem below. Right. Okay, so we have bases 4 and 128. We have an external base, which is 2. When we encounter these types of problems, when we see that there's another integer or constant that is outside the main base, all we have to do is to divide both sides with that number. So in this case, never mind, I'll just write it traditionally. So 4 raised to 2x plus 1 is equal to 128. Divide both sides by 2. We get 4 raised to 2x plus 1 is equivalent to 64. And in that case, we have two choices. We can solve this in two ways. So for way 1, we just keep keep this part as 4, the base as 4, and the other side would be 4 raised to 3. Then we cancel both sides. We get 2x plus 1 is equal to 3. 2x is equal to negative 2. I'm sorry for a while. Give me a few seconds to check again my solution. I might get mistakes. Okay. I suggest that we try solution 2 or way 2. So we have 4 raised to 2x plus 1. We turn the base into 2. So 2 raised to 2 times the quantity 2x plus 1, which is equivalent to 4x plus 2, is equal to 2 raised to 4, I think. Hang on. I'm sorry. 2 raised to 6. We cancel both sides. We cancel the bases of both sides, and 4x plus 2 is equal to 6. 4x is equal to negative 4. Huh. 4x is equal to negative 1. And also at solution 1, we get negative 1. It's pretty interesting. I'm not sure why, but the answer is positive 1. I need a few seconds. I apologize for the delay. You may skip this part if you're in a rush. I need a few seconds. Alright, I'm back. Let's see. For solution 1, so 2x plus 1 is equal to 3. I'm sorry. I apologize. I see my mistake now. 3 minus 1 is positive 2, not negative 2. 6 minus 2 is positive 4, not negative 4. So yeah, x is equal to positive 1. Just a minor mistake, but that could really make a difference. 1 and negative 1 are different. Okay, for number 6, let's answer it here. Okay, this time, I suppose that you can see that the equation is harder to solve. But if you know that, for example, we have a radical expression here, and assuming that the exponent of the base inside is 1, and of course, by default, the radical sign is 2, has a number of 2 here. If we convert this to fraction, of course, our base will be this way, written this way, and the exponent of that base that's inside the radical sign will be our numerator, and the number of the radical sign will be our denominator. So if we understand this general concept, we can solve this easily. We don't need to use any calculator or any math solver or calculator. We just need our mind. Okay, so in this part, we have 3 as our base. By default, of course, 3 is equivalent to 3 raised to 1. So it's obvious that our numerator is 1, and our denominator is the number of the radical sign. I'm not exactly sure how to call it. I suppose I've forgotten it, unfortunately. Radicand, I'm not sure. But I suppose you, the audience, maybe some of you know it. Good for you. Please keep that in mind. It's really important. Okay, just copy the rest of the parts of the equation. Our base is still 3 at the other side, at the right side of the equation. Our numerator is 1, our denominator is 8. Then we just copy for x with the multiply part. Now, I think it's pretty clear that we can cancel the bases and make the exponents before our bases now. 1 over 5 times 5x minus 10 is equivalent to 1 over 8 times 4x. Whereas, 1 over 5 times 5x is x, and we get negative 2. 10 times 1 over 5. For 1 over 8 times 4x, we get 1 over 2x. Right, so for x, I'm sorry, x minus 1 over 2x equal to 2. 1 over 2x equal to 2. Multiply both sides by 2, we get x equal to 4. So this is our final answer. Right, that's it. Let's check everything. Okay, number 1, no solution, no solution. 4, xer, x equal to positive 1, x equal to positive 4. Alright, that's it for this video. I hope you've understood at least something from this, and I hope it's beneficial. Thank you for watching.